Hey guys, Daniel here. Been away for a number of months, but I'm back home and it's a new year. Thought it was finally time to get some more videos up and going. So the first thing I wanted to talk about this year was the difference between the original version of Kangaroo and the new version of Kangaroo. I get so many questions about this, both in my videos and in my inbox, people asking me, why does my Kangaroo look different to your Kangaroo, or why do I not have this component or that component? Well, this video should answer a lot of that. And the way we're going to do it is basically by creating a very basic definition in both version 1 and version 2. Now quickly just flick over to the Food for Rhino website because I wanted to just be very explicit with what these versions are. So I'm using version 0.099. So anything this version and prior, that's to say these ones down here, all run under the same sort of method. They all look very similar. And then Kangaroo 2 and above got a massive overhaul. Daniel Piker, the guy who writes Kangaroo, rewrote everything from the ground up. And in fact, there's just been a release just about a week ago. That's 2.2.1, and that's the version I'm going to be using in this tutorial as well. So one more time, we're going to be comparing 2.2.1 with 0.099. Alright, so let's flick back to Rhino and Grasshopper. And now one thing more that I want to say before we get started is that this is going to be a tutorial on sort of both versions of Kangaroo at the same time. And the reason I say both is because I don't think that the Kangaroo 1 is by any means a bad physics simulator. I think there's still a lot of merit in using it. And I would not discount it immediately. I still recommend to some people to look at the original solver just because of material that's out there online, and and in my mind it does still do some things better than the new version of Kangaroo. But without further ado, let's get into it. Okay, so we're going to just create a super basic setup, and for that I'm going to need a mesh plane, and I'm going to plug that into my geometry input over here and just line it up so it's nice and straight. And in order to get a simulation going, we need a couple of things. We need geometry, we need force objects, so I'm going to pop over to the Kangaroo 1 tab, and I'm going to grab some forces. So the two forces I'm going to be using for this are my unary force, which is gravity, and I'm also going to be using my springs from line, which is right over here. And so the springs from line, the springs component is integral to pretty much every simulation you will ever do. It's kind of the backbone. It basically holds the mesh together. And so what we need is some sort of connection. And the connection is a line, so a line connecting 2 points, as it says there. And so in order to get that, there's two ways we can do that. If you don't have Weaverbird, which you may not, you can just use the default the default Grasshopper mesh edges component, which gives you a list of 3 edges that you need to plug into the connection. But I prefer to use Weavebird's mesh edges just because it gives me a single output. It's just a cosmetic thing, doesn't really do anything differently. And then my line is going to go into the connection over here. And then I'm also going to do my unary force, my gravity. So gravity requires a point, which is going to be all the points in the mesh. So I'm going to extract those with a deconstruct mesh node. I'm going to connect my vertices in here. And I also need a force. So for the force I'm going to use a z vector, even though by default it gives me what is in terms of the Earth, the nominal considered value of gravity, negative 9.8. But I'm going to override that with a z vector which just has a value of 1 at the moment. And I'm also going to plug in a slider for my control. And one thing I haven't talked about before is means of accessing sliders from the search function. Of course, you can grab sliders from your params inputs over here. You can also grab it by typing in slider, but what you can also do is you can type in values to initialize your slider straight away. So for instance, if I wanted an integer slider between 0 and 10, I would type in 0 is less than 10 or between 0 and 10, and it would give me an integer slider. But if or maybe I wanted a floating point slider, so I could type in between 0 and 10, and if I specify some amount of decimal points, it will give me a slider with that level of accuracy. But what I could also do is I could set up a slider and give it a default value. So for instance, I could set it between 0 and 10, with 5 being in the middle, and that would set my slider to a value of 5. But what I actually want is a slider between 0 and 100, so I should have done that to begin with. Okay, so I'll delete these, plug this in here, line it up, and we'll just pan over slightly so I've framed everything up. And now we're going to connect in our force objects. And one thing that I never did before, which I really regret because I think this is a really good practice to get into, is using merge nodes. So before, anytime I would connect multiple inputs or multiple streams into an input, I would drag them in and then grab another one, press the shift key, and drag it in as well. And that's all well and good. You have technically connected both inputs in there, but I think it's much better to connect them into a merge node separately. A merge node will always add a separate another connection point if you want to add more data. But I think the beauty of this is that it's a lot more verbose. You can see what order your data is coming in. Sometimes that's very important to know what order things are coming in. You can toggle them, or not toggle them. You can pull them out easier. And then when we connect this up, we can also see that our data structure has changed. And this is very key to Kangaroo or Kangaroo version 1 simulations especially. So now I'm just going to preview off my unary forces, my force objects, and also I've noticed that my Kangaroo, or my force value is currently set to 0, so I'm just going to quickly set that to 1. Okay, and in order to run the Kangaroo simulation, there's a couple of ways you can do it. You can either double click the component and this dialog will pop up, so you have stop, play, pause, end, next, but I prefer to do it with a timer and a button. Key thing that I should also note at the moment as well is the way the simulation works is that this value coming into simulation reset needs to be set to false. As long as simulation reset is true, that means the simulation is constantly resetting, so it's never calculating anything. In order for it to run, it needs to be set to false with a false value. But you will see an error be thrown here, and that's because I have not flattened my force objects. That's a rookie mistake. Always flatten your force objects for Kangaroo 1. And the way we can do that, we can either do it here or here, doesn't matter, does the exact same thing, but instead of popping all the way down to this and hitting it with the mouse, I can just right click over here and use my F key for flatten. Similarly, I could do the same thing with graft if I needed to graft, but I need to flatten, so I'm going to flatten. And then if I reset the simulation, okay, it is now working. But it's going very slow because it's currently updating at 1 second intervals, so I'm going to change it to 20 milliseconds. And you'll now see it's working, but it's converged to basically nothing because I have no anchor points constraining it in any sort of way. So I need some anchor points. And the quickest way I can do that is just by bringing in a mesh corners component. This is a cluster that Daniel Piker formed. It comes under your Utilities tab. I can't quite remember if you need to install the user object as well. I think you might if you don't have it, but those come in the Kangaroo setup files. So we plug our mesh in, and this will give us the four corners of the mesh based on some sort of angle tolerance. And so now we have these, and we'll plug those into our anchor points, and you see the simulation is going to throw an error because if you make changes while the simulation is running, it doesn't really like that. So from now on, I'm going to change to this button because the button is a much better way to run simulations. The button is basically false until you hit the button and it becomes true, and it basically resets the simulation. Super useful. Let's get rid of this boolean toggle, and then we'll double click our timer to get the simulation going. Okay, let me preview some of this geometry off now. And also, a quick note, the Kangaroo component by itself has a display option, but I prefer to use a geonode on the output because it doesn't give us all the point information and clutter, you could say. It just gives us a much cleaner output. And so now I'm going to ramp up my value to 100. And also one other thing I need to do is the springs, by default their rest length is set to 0. This means that the simulation is running under complete tension, and these lines are always going to try and minimize their length. And we don't necessarily want that to happen. So the way we fix that is by, let's just grab all of this and give us a bit more space. So the way we get around that is by grabbing a length component. So we grab the length of all these edges, we plug them in to a multiplier, and then we just grab a slider and connect it up and connect that into our rest length. And then now we have parametric control over the rest length of our lines. Okay, so I'm just going to leave this at 1 for all intents and purposes. And let's see, is there anything else I needed to do on this simulation? Probably not. We'll pause it and we'll move on to Kangaroo 2. So now we're basically going to do the exact same setup on the Kangaroo 2 solver. So once again, we're going to grab a mesh plane. We're going to grab the edges, and we're going to grab the mesh corners. And okay, so now we need our 4 subjects, except they're no longer 4 subjects. This is probably the biggest difference about Kangaroo 2. We're no longer using 4 subjects to control the simulation, but rather goal objects, meaning that we're trying to get the solver to tend to one solution. We're trying to get an optimal solution out of our solver. It is eventually going to converge to a single solution. I just said a lot of things there which all basically meant the same thing. And so if we pop over to the Kangaroo 2 tab, we see that we now have a collection of goals. And so let's find our springs, except some of them have changed name. So the springs is no longer called springs, it's called length. So we're using a length solver, and we'll plug our lines into the length solver. And now, by default, the length is going to be the rest length, which is pretty useful. But I'm also going to just copy and paste this because maybe we do still want some more parametric control over the length of our lines over the length contraction in our simulation. Okay, and we're also going to drop in a merge node. Okay, so those are our springs, or our length goal objects. We also need a unity force, which is no longer called a unity force as well. It is now called a load. Okay, and so load requires the same things. It requires mesh vertices to work on, or just vertices in the simulation to work on. We'll plug those vertices into our points over here, and then we also need a force vector. So our force vector is going to be a unit z, and then I'm going to plug that into my merge. And okay, now what else do we need? We need our anchors, and our anchors are also goal objects. They do not plug straight into the solver anymore. So our anchors, we plug. Let me bring these down here actually, just so that we were working in order. Bottom to top, left to right. It's better. Okay, so now we have our anchors, and now we probably have enough to get the simulation going. Okay, and you may have completely missed what happened there. Let me just grab a geonode. Actually, no. So this is another interesting thing about the Kangaroo 2 solver, is that the geometry that you put in is the geometry that you get out. So if you don't plug a mesh in directly in any sort of way, you don't get a mesh output. And the way we have to do it is with this new method, which is called the show method. So what do we want to show? We want to show this mesh, and this show method is also a goal object. Okay, and so there we have it. And now, what is also really interesting about the way this show method works is that the geometry pre-simulation is actually affected. So let me see if I can explain this. Like over here, this is our output, this is our final result, but this is our input, and you can see that our input has actually changed in comparison with the input over here, which is, in my mind at least, kind of strange. And the show solver, or the show goal, doesn't actually do it. It doesn't actually show it itself. So I don't know. Maybe you like that. Maybe you're like me and you don't like that so much. But we can just preview it on by turning this on over here. And you know, we've got control over here, but you'll notice it's not bouncing in the same way that this simulation does. And that's one thing I really like about the initial version of Kangaroo. If I change the spring length over here, and I turn the simulation on, you can see we've got a lot more bounce going on here. It's a bit more physically accurate. So let me just preview that. I'll pause that simulation. So what we have actually, if we do want to achieve something a bit more like our original Kangaroo solver, is we have different kinds of solvers now in Kangaroo 2. So we have the bouncy solver, and the bouncy solver works. The bouncy solver is really interesting because we can get some really interesting control over the simulation once again. So I'll plug my goal objects in, and it's going to throw an error because we need a button to reset. And I'm going to have to reset this solver as well, because at the moment it's working on this geometry, which is not the input geometry that we have. Okay, so there you can see we are getting a much more version 1 type of simulation. But you'll also notice this is going to converge. Okay, so what can we do with the bouncy solver? We can grab a slider and we can control the amount of sort of sub-step calculations. So if I give this a maximum value of something like 50, 50 might be a bit absurdly high. But if I plug this into my iterations here, and I'll just set it to 1 for now. So this is the amount of steps in between every result that we see. So if I hit this button, we're going to get a much more interesting kind of fluidy, folding, more, I guess, jellyfish-like result, which is really interesting. Whereas if I set this to somewhere like 50, so it's calculating a lot more steps a lot faster, so we don't see as much of the in-between. So when I reset this, it's very, very quick to give me a solution. So by default, the default value for this is somewhere around 10, so it has a bit of bounce to it, but not an absurd amount so that it is so much jellyfish-like, as I just said. And we'll just wait for that to converge. And so that is probably the main difference between these two solvers, that this instantly gives you the result, and this well, this obviously is the bouncy solver. It has some bounce to it. Now we also have another kind of solver, and that is the, let me see, where is it? That is the step solver. Now this is probably the closest version. This is the most akin to Kangaroo 1, in my opinion at least. I guess it is debatable. So once again, we'll plug our goal objects in, but we don't have a reset this time. We have an animate. And so the way this works is we just need some sort of value that's going to change in order for this to animate. So we could either use something like a counter. We'll plug that in, and we'll need a button for our reset, and we'll need a timer. And so every time this value changes, it's going to the result is going to step forward. But we do still have the bounciness of this solver attainable in this solution as well. You can see the iterations here is basically the same as sub-iterations over here. So if I drag this out, set this to 1 like I did before, and then reset this button here, I can pause the simulation. This is something you can't do with the other two solvers, I believe. Maybe you can. Maybe you can actually. In fact, let me check that before I'm spitting nonsense. If we grab a boolean, and actually let me do it on this one, because this one makes a bit more sense to do it on. Which result is this giving me? It's quite difficult to tell. Let me disconnect these, reset that, and then let's set this. Okay, so you can pause these. Yeah, but you need, okay, in my mind though, it is a bit easier to do it with this one. And the way you do that is, let's just plug our goal objects in here, reset simulation, double click this, double click it again to pause. Or another way you could do it, because all this is asking for is a changing value. As long as the value is greater than 0, you're going to get animation. And so what this means is, in fact, you can just plug a slider in here, and you can change as much as you like, and then as soon as you let go of it, the simulation will pause, and then if you set it back to 0, the simulation resets. So here I am, just progressing the slider forward, and then reset it. Yeah, a really nice way to control the animation, if you will. I mean, I do a lot of animation with Kangaroo, and I think this is actually quite a nice way to work with it. Okay, and now one last thing that I want to talk about Kangaroo 2 with is the grab goal. Now this is a really cool feature, something that you definitely can't do in version 1 of Kangaroo, and it's really simple to set up. Basically, you need a boolean to ensure it's on. By default, it's set to true, so it is on. We plug this into our goal objects, and in fact, I'm going to plug this back into our bouncy solver for this test. I'm going to set this back to true. Maybe I'll bump my iterations down so we've got a bit more jellyfish kind of geometry going on. And let's just reset this. No, I don't want that much jellyfishing. Maybe I want this somewhere a bit higher. Yeah, something like that is working for me. And so with the grab solver, with the grab goal, if you just hover over this, it tells you how to use it. You hold the Alt key and drag with the left mouse button, and we can basically directly interact with the geometry inside of Rhino, which is really cool. If I take the strength down on this on these lines, well, not that much. Let me set this to 10. You can really have a lot of fun with this. I mean, especially if you have a lot lower tensions and maybe a lot lower loading. Let's try really lower the load, lower our strength, and you can see how this will be a lot of fun. Daniel Pike has done some really cool videos showing what you can do in the new Kangaroo solver with the grab objects. You can do some really cool kinetic simulations. Maybe I'll show some of those further down the track. But there's just maybe one. I think he keeps saying one more thing that I want to talk about. We'll see when I finally get to the list of things. When I finally get through the list of things. So the other thing to note is that there's sort of Daniel's sort of tried to unify the strengths across components a lot more. So you'll notice that when this was at 1, let me set the strength back to 10, and I'll just turn this off and go back to my my original solver. Let me set that. Okay, so if I compare this result with this result, you can see they're pretty close to each other, but over here I only have a force vector loading of 1, whereas over here I had a force vector loading of 100. And then if we look at my springs, spring stiffness was set to 1000, whereas over here it's only set to 10. So he's really tried to bring these values, or really tried to unify the values a lot more. So a value of 1 across most of these will still do quite a lot of, how shall we say, a lot of brunt work, or it'll still have a pretty strong effect. But what is really interesting to to note actually is that because the anchor is now a goal object, that means that the geometry doesn't actually sit. It's not actually a 100% tight anchor. It has some sort of elasticity to it, where if we compare this result, you can see the point is slightly off the origin as compared to the original simulation, which is bang smack at where the anchor should be. So for me, this is a really interesting sort of dichotomy about the new Kangaroo solver, is that the anchors, you can even change the strength of the anchors. So at the moment it's set to 1,000, and this is obviously because anchors require a lot more strength in order to work. And so if we dial this back, you can see the anchor is losing a lot of its pull. And if we were to plug this into here, we might actually see, yeah, you see the whole geometry, the whole point moves in and of its own accord. And that's a really interesting result of the way the new Kangaroo solver works. And one sort of, I guess maybe this is the final thing that I talk about, is that the springs component had a lot more parameters to work with before. I think you could really harness and gain a lot more control of what the original solver was doing. And for me, these two things, the anchor tightness and the way the springs component worked, are maybe the main reasons why I keep coming back to Kangaroo version 1. They're just some of the things that in my mind work a little bit better. So my advice, once again, don't discount Kangaroo 1 just because it's old. It's still a great solver, but at the same time, you know, you might just as well find that Kangaroo 2 is leaps and bounds better, and especially with some of the new features, it might absolutely 100% be a thing. Okay, so that's it from me. Hope you guys really enjoyed this video. Like it, subscribe. Yeah, I'm getting on that bandwagon now because I'd love to have more people on my channel. Yeah, join up. Thanks everyone.